Ever felt like you're navigating a vast ocean of information without a clear map? Maybe you're looking at a new product launch and it isn't quite hitting its targets, or trying to understand why a crucial business process just keeps stumbling. Well, today we're diving into the fundamental skills that let you really master data, how to find it, connect it, and even paint a clear picture with it. We're going to pull back the curtain on the tools that let you truly understand the what and the how behind your business.
Indeed. We're aiming for those aha moments, transforming what might feel like information overload into, well, actionable insights. We'll unpack the essential concepts that allow us to ask smart questions of large data sets, combine information from different sources, and visually map out complex processes so they just make perfect sense.
Absolutely. So whether you're trying to diagnose a business problem, maybe you're curious about a new field, or you just love uncovering surprising facts, we've got you covered. By the end of this deep dive, you'll have a clear grasp of data extraction using SQL, the power of data integration, and how to visualize processes with tools like BPMN and DFDs. Let's get started. All right, imagine you're a detective. Okay? And your clues are buried deep in some massive digital archive. How do you ask precise questions to get exactly the info you need? That's where SQL comes in, structured query language. It's basically the language you use to talk to data in a relational database.
Right, and think of a relational database like a super organized library, information stored in linked tables, making sure things are accurate, efficient. For data analytics, our main job with SQL is really viewing and extracting specific data, the stuff that matches our analysis goals.
Okay, makes sense. Like asking the library for specific books, not the whole shelf.
Exactly. But here's where it gets critical, even before you write that first SQL query. You must understand the data you actually have access to. It's not just knowing the tables exist, it's how they relate, how they connect, especially through their primary and foreign keys. These are like the unique identifiers and the links between tables.
Ah, okay. So like knowing the library's catalog system first.
Precisely. This foundational understanding often laid out in things called data dictionaries, which tell you what each piece of data means, and data models that map how tables connect. It's absolutely integral. Without it, you're just guessing, honestly. And you'll feel overwhelmed pretty fast by just the sheer volume of data.
So just to make sure I'm fully getting this, if I don't understand these relationships and keys, what's the worst case scenario? Am I just pulling inaccurate numbers, or could it lead to completely flawed business insights?
Oh, it's definitely worse than just inaccurate numbers. It really leads to flawed insights. If you try to combine tables incorrectly, maybe join them on the wrong thing, you could end up with duplicated data or missing records, or even just completely misinterpreting what a column actually means. It's like trying to navigate a city with a map that's got wrong street names and, missing roads. Your analysis won't reflect reality, and any decisions based on that analysis, well, they'll likely be pretty ineffective.
Okay, wow. That really clarifies why that foundation is so crucial.
Okay.
Got it. Now, to actually speak SQL, you build queries from, well, what we call SQL commands. These are the specific words like select, from, where, and database elements like table or column names. These combine to form SQL clauses. You mentioned uppercase for commands is common, just for readability.
Yeah, exactly. Case doesn't technically matter for the commands themselves, but writing them in uppercase like select from it just makes the query much easier to read, distinguishes the commands from your table and column names. And these SQL clauses, these phrases, they form sentences, but they follow a very specific required order. You can't just mix them up. Typically, SQL queries always start with two essential clauses, select and from.
Okay, let's unpack those foundational two first. If I'm just getting started and want a quick overview of like everything in a table, is there a simple way to just peek at all the columns?
There absolutely is. Select, that's the star symbol, is your shortcut. It means select all columns. It shows you every attribute or column in its original table order. It's great for a quick look, yeah. But a critical insight for efficiency, especially with massive data sets, you should always explicitly list the columns you actually need.
Ah, okay. So don't just grab everything if you don't need it.
Right. If you just want, say, first name, last name, and state from your customers table, you'd write select first name, last name, state. This not only speeds up your queries, sometimes significantly, but it also ensures your analysis stays focused only on the relevant information. Keeps things clean.
That makes a lot of sense. Keeps things clean and efficient.
Okay.
And then the from clause. that just tells the database which table has those columns you selected.
Exactly. So if those first name, last name, and state attributes come from your customer's table, you simply add from customers. Putting those two together, you get your first runnable query. Select first name, last name, state from customers. Simple as that.
Got it. The essential duo.
Precisely. It gets you the basic data out. And a quick tip here. If you change the order of the columns in your select list, it changes the order of the columns in your output, how they appear, but it won't change the number of records you get back. It's purely about presentation.
All right, okay. Now, a simple select from is useful, but here's where we add precision, I guess. Filtering. Like filtering a spreadsheet, the where clause lets you narrow your results down. It's your precision tool. It lets you hone in on the exact data points that truly matter for your analysis. For our struggling product launch example, we might need to filter sales data for, say, a specific region or a specific time period.
Exactly. The basic idea is where, then the column name, then an operator like equals, and then the criteria. So where, column name, exiles is criteria. But here's a quick tip on formatting that trips people up sometimes. It depends on the data type. If you're filtering text, like a specific state name, you absolutely must put the criteria in single quotes. For example, where state equals AR. But if you're filtering numbers, like sales price, no quotes are needed at all. Just where sales price 10. Understanding your data type saves a lot of headaches here. Dates often need special formatting too, but that's a whole other topic.
Okay, quotes for text, no quotes for numbers. Got it. That's powerful for filtering individual records, individual sales, for instance. But I can already see how, for deeper business insights, we often need to look at data at a higher level, right? Like totals or averages, not just individual sales lines.
Absolutely, you're spot on. This is where SQL aggregate functions come into play. They let you create grand total or subtotal values across many rows. We're talking
Yeah.
about functions like SUM for totals, count for counting rows, AVG for average, MIN for minimum, and max for maximum. So if our product launch detective wants to know the total number of sales orders, not each individual one, they'd use something like select count sales ordered from sales orders.
Okay, count gives the grand total.
Yep. And this leads us to a really fascinating insight, how to get subtotals instead of just one big grand total. This is where Group E by becomes essential. If you want to group your aggregated data by a specific category, say you want to see how many sales orders each individual customer has, or maybe how sales perform per region, you add a Group by Y clause.
Okay. So you tell it how to group to summary.
Exactly. So you'd put both the category you're grouping by, like customer id, and your aggregate function, like count sales ordered, in your select list. Then, after the from clause, you add group by customer id. The full query would look something like select customer id, count sales ordered from sales orders group by customer id. This immediately gives you a summary line for each unique customer.
That's incredibly powerful for quickly seeing trends across different segments, like who are my top customers by order count. Now, when you're using Group by Y to get these subtotals, you might still want to filter those results, right? Like only show me customers with more than 5 orders. But here's the catch you mentioned. SQL can't filter these aggregate measures using the where clause, is that right?
That's exactly right. Where filters rows before they get grouped and aggregated. So you need a different clause for filtering the results of the aggregation. And that clause is having.
Having.
Okay. Having works conceptually like where, but it's specifically applied after the group by Y calculation has happened. So if you've grouped your sales by customer and want to see only those customers who bought a total quantity of more than 200 units, you'd add having some quantity sold, 200. It lets you filter on the results of your summary, not just the raw individual records. You can use operators like equals, less than, greater than, not equal, etc.
Okay, where for rows, having for groups. That makes sense. So we've talked about extracting data within a single table, summarizing it. But relational databases, as you said, are designed to reduce redundancy. That often means important details are spread across different tables, right? Like our product launch team might need the phone number for each customer associated with their sales orders. The orders are in sales orders, but the phone numbers are in the customer's table. To bring this stuff together, you need to identify the matching keys between the tables, like a customer ID that exists in both.
This is exactly where SQL joins come in. They are absolutely fundamental for integrating data from different tables stored within that relational database. The most common type you'll encounter is probably an inner join. It retrieves only the data where there's a match in both tables you're joining. Think of it like the overlapping part of two Venn diagrams.
Right, only where they match up.
Right. So if you wanted customer names and their sales orders, an inner join would connect the customer's table and the sales orders table on the customer ID field they share. But what's really crucial to understand here is what an inner join excludes. If there's a sales order in the sales orders table that for some reason doesn't have a matching customer ID in the customers table, that order won't show up in your results, and vice versa. If you have a customer in the customers table who hasn't placed any orders yet, they won't appear either.
Okay, so inner join is about precision, only showing the full match. Perfect overlap. But in a real-world scenario, wouldn't we sometimes want to see that unmatched data? Like which customers haven't placed an order yet? That seems useful. Or maybe sales orders that have missing customer info to flag a problem?
Excellent question. Yes, absolutely. That's precisely why we have other types of joins, most notably left joins. A left join is what you use when it's important to see all of the data from one particular table. We call this the left table, even if there isn't a matching record in the other table, the right table. So if you need to see every single customer, even those who haven't placed an order yet, you'd use a left join, starting with the customers table.
Ah, so the order matters with left join.
Yes, definitely. The order of tables does matter. The table you list first in the from clause is considered the left table. The left join guarantees that all rows from this table will be included in the results. If there's no match in the right table, the one mentioned in the left join clause, the columns from that right table will just show up as NLL or empty for those rows.
Wow, okay. That's a really powerful set of tools just within SQL. It feels like we've covered a lot. Yeah, just to quickly recap. Select to choose what you see. From specifies the main table. Where filters individual rows before grouping. Group by Y aggregates data into subtotals, having filters those aggregated subtotals after grouping. And then joins, like inner and left, let you connect data across different tables based on matching keys. It's truly a foundational toolkit for precise data extraction.
It really is. Mastering these core SQL commands gives you incredible power to interrogate your data.
Now, that was a fantastic deep dive into extracting data within a single database system. But the real world often isn't so tidy, is it? What happens when your customer data is in one system, maybe Salesforce, your sales figures are in another, like an ERP database, and your marketing spend for that product launch is sitting in, I don't know, a bunch of spreadsheets. That's when we need to move beyond just extraction to the art of data integration.
Exactly. This is where most popular data analysis and visualization tools really shine. Think Excel, Microsoft Power BI, Tableau, Alteryx. They have built-in connectors. They're designed to connect to a huge range of common applications, data warehouse tools, databases, even web services. The true insight of data integration isn't just about, mashing spreadsheets together. It's about dissolving those information silos between different systems. When you bring that data together, you can reveal a holistic, actionable truth about the business. It empowers organizations to spot trends and make cross-functional decisions that were basically impossible when all that data lived in isolation.
Right, you can finally see the whole picture. This isn't just theory, it's how real-world decisions get made and how you'd get that comprehensive view of our maybe struggling product launch's performance. Like, for example, in financial analysis, companies routinely combine their internal financial statements with external market data, maybe from sources like Bloomberg or Yahoo Finance.
Yeah, they do that all the time.
And why? It's to compare their own performance relative to industry peers, right? And to factor in broader economic conditions, things like interest rates, inflation, GDP growth. That integrated view gives them the full context, the bigger picture.
Precisely. And similarly, for operational analysis, relevant data is often spread across completely different databases or systems. Integrating this data is absolutely crucial for assessing performance and making, timely decisions. Think about combining data from a production database, how many units we made with supply chain data, what materials we have, where they are. This allows analysts to pinpoint inefficiencies, like maybe over or under production for our new product. Find those bottlenecks. Then, production schedules can be optimized, which directly impacts the bottom line, saves money, reduces waste.
Okay, so once you've meticulously extracted your data with SQL, maybe pulled data from other sources and integrated it all together, you've got the pieces of the puzzle. But how do you make sense of the intricate how behind your business operations, especially when it comes to the processes that generate all that data in the first place? That's where visualizing these processes becomes your kind of ultimate storytelling tool, isn't it?
It really is. Flowcharts are very common tools for depicting these process or data flows. They help analysts and really anyone in the business understand the process. And then, crucially, analyze them for improvement, whether that's improving effectiveness, efficiency, or maybe strengthening internal controls. We'll look at two key types today. First, BPMN, that's Business Process Modeling Notation. It's used for activity models, which focus on the actions and responsibilities, who does what. And second, data flow diagrams, or DFDs, these are used specifically to describe the flow of data through a process. Where does the information actually go?
Got it. BPMN for activities, DFDs for data flow. Let's start with BPMN activity models. You said it's a standardized tool. Like, there are specific rules and symbols everyone agrees on.
Yes, exactly. BPMN has a specific set of symbols and rules. This standardization is key because it means users share a common language to communicate business processes so they can be easily documented, understood, improved, managed. It allows everyone from, say, a sales rep to a CEO to look at the same diagram and understand how our product launch process actually works, step by step.
And that standardization probably helps with analysis too.
Hugely. This is where BPMN offers a massive strategic advantage. These models can actually be systematically analyzed to identify process areas ripe for automation. There's a sort of widely recognized rule of automation that basically states the more rule-bound and repetitive a process is, the easier and more cost-effective it usually is to automate it. Once BPMN models clearly map out all the steps and the decisions involved, you can immediately spot those opportunities for potentially significant cost savings and efficiency gains.
That's a really powerful insight. Automation opportunities hiding in plain sight on the diagram. Okay, so let's break down the core components of BPMN. First, how do we show who's actually involved in a process?
That's handled by two key elements: pools and swim lanes. Pools represent the major participants, usually different organizations or entities. Every BPMN model needs at least one pool, typically representing your internal organization. So for example, in our product sales process, you might have a selling organization pool and a separate customer pool. Shows the main players.
Okay, pools for different organizations
Right.
and swim lanes.
Swim lanes provide more granularity within a single pool. They indicate the different roles, departments, or even specific individuals responsible for different tasks within that organization. It shows segregation of duties. So your selling organization pool might be divided into a sales representative swim lane and a cashier swim lane, clearly showing who is responsible for which steps in that sales process.
Makes sense. Pools for organizations, lanes for roles within them. What about the start and end points?
Those are events, always shown as circles. They define the critical junctures, the beginning, the end, or key moments that might alter the process flow. A simple, smooth circle indicates a start event, usually only one per pool. A thicker, bold circle indicates an end event, and you can have multiple end events showing different ways a process might conclude. And then there are intermediate events, shown with a double-line circle. These signify something changing mid-process, maybe a time delay, or an error occurring that needs handling.
Okay, circles for start, end, and intermediate events, and the actual work being done.
Those are the tasks, represented by rectangles with rounded edges. These are really the fundamental building blocks. Every distinct action or step in a process gets documented as a task. Think of things like process order, update inventory, send confirmation email. Each action is a task.
Got it. Rounded rectangles for tasks. And how do we connect all these pools, lanes, events, and tasks together? Show the flow.
That's done with sequence flows and message flows. They're both types of arrows, but used differently. Sequence flows are solid-lined arrows. They connect every object within a single pool, showing the mandatory progression of steps. You read them generally from left to right, showing the order things happen in. They connect start events to tasks, tasks to other tasks, tasks to gateways, gateways to tasks, and finally, tasks to end events, all within the same pool.
Okay, solid arrows within a pool show the sequence. What about the dashed ones, message flows?
Right. Message flows are dashed arrows. These are used only to indicate communication between two separate pools, never within a single pool, not even between lanes in the same pool. The direction of the dashed arrow shows the direction of the communication. For example, the customer pool might send a message flow labeled product information to the sales representative lane in the selling organization pool.
Okay, dashed arrows for communication between pools. Got it. One more symbol you mentioned. Gateways, diamonds, what do they do?
Gateways, yes, shown as diamonds. They are crucial decision points or branching points in the process. They represent moments when a task doesn't just lead to one next step, but could lead to two or more different paths based on a condition. Think of them as questions, not tasks themselves. So the label on a gateway should always be a question like sufficient quantity available or payment approved. If a task could have multiple outcomes depending on an answer, that's your signal. You need a gateway after the task to illustrate the different paths the process can take based on the answer to that question. A task itself should only ever have one sequence flow leaving it.
Okay, so the gateway handles the branching logic. That clarifies things a lot. Now, BPMN seems fantastic for showing who does what and when and the decisions involved. But you mentioned sometimes we need more details specifically about how the data itself moves. That's
Yep.
where data flow diagrams, DFDs, come in. You said they offer a more granular look at the journey of the data.
That's exactly right. DFDs provide invaluable insight into how data moves through a process or system, something BPMN activity models alone don't focus on as much. Understanding these data flows lets you pinpoint potential bottlenecks in information transfer, or even identify where critical data might be getting created, transformed, or potentially lost, which is key for true process optimization and data integrity. And they use fewer symbols than BPMN, which can make them simpler to grasp initially.
Fewer symbols, okay. What are they?
There are just four main objects in a data flow diagram. First, there's the process, usually depicted as a rounded rectangle or sometimes a circle. This indicates any action or function that actually transforms data, takes inputs, and produces different outputs, like input customer information or calculate sales tax.
Okay, process transforms data. What else?
Second, the data flow itself, which is simply an arrow. It shows the direction that data moves between processes, data stores, and external entities. Critically, the arrow should be labeled with the specific data that is flowing, like customer contact details or validated order.
Arrow shows data moving. Labeled with what data it is.
Yeah.
Third,
Third is the data store, or sometimes called a data warehouse, shown as an open-ended rectangle. This indicates where data is stored for later use. This could represent anything from a database table, a specific file, a SharePoint folder, or even, a physical filing cabinet in older systems. It's where data rests.
open rectangle for storage. And the last one.
The last one is the external entity or terminator, usually shown as a square or rectangle. This represents something outside the system or process being diagrammed that either provides data to the process or receives data from the process. Common examples would be a customer, a supplier, a bank, or another department or system that interacts with the one you're modeling.
Okay, square for external sources or destinations of data. So let's try to quickly trace our product launch data flow using these. Maybe a customer external entity provides customer details data flow, which goes into a customer details process. That process then sends formatted customer data flow, to a customer relationship system, data store. Is that the idea?
Exactly. And maybe in parallel, that same customer, external entity, provides payment information, data flow, to a payment details process.
Right.
That payment process might then send payment transaction data, data flow, to a cash receipt database, data store, and also send deposit information, data flow, to an external entity like a bank.
Wow, okay. It really does illustrate how these diagrams make that invisible flow of information, well, visible. You can see exactly where data is created, where it's changed, where it's stored, and where it ends up. That seems incredibly useful for understanding and troubleshooting.
Ew, what a deep dive that was.
From talking to databases with SQL to extract precisely what we need, dissolving those information silos through data integration, and then visualizing the intricate dance of information and processes within an organization using BPMN and DFDs, we've really covered a huge amount of ground today.
We really have. That highlights just how foundational these concepts are for, well, anyone looking to understand, analyze, and ultimately improve operations in pretty much any field. Knowledge is most valuable when it's understood and actually applied, right? And these tools give you that power to understand and apply.
Absolutely. And now, as we wrap up, here's your final provocative thought to chew on. Think about a simple process in your own life or work, maybe something as straightforward as organizing your digital photos, planning a trip, or even just managing your daily to-do list. How would you start to describe that process using some of the core concepts of BPMN we talked about? The tasks, the events, maybe even a gateway. And then think about what kind of data that process generates. If you could capture that data, what kind of SQL query might you write to gain a surprising new insight from it?
That's a great exercise. There's always more to learn. And applying these different perspectives, the process view, the data view, it truly enriches your understanding of almost anything. Keep questioning, keep exploring.
Well said. Thanks so much for joining us on this deep dive. We really hope you feel a little more well-informed now and maybe a lot more curious about the data and processes around you. Until next time.